In this video, we're going to talk about velocity time graphs. You've already done position time graphs, and these are just a little bit different. One of the things I want to show you about these velocity time graphs is that right here, you have velocity. Okay, in your other graphs, you have position here, but now you have velocity, and the units are meters per second. You still have time here. Nothing changes about that. Okay. So you have velocity on the y-axis and you have time on the x-axis. Now, when you do your slope formula, you have y2 minus y1 over x2 minus x1. Okay, the units for the y-axis are meters per second. And the units for the x-axis, which are on the bottom, are seconds, which gives you meters per second squared, which means the slope of your graph is acceleration. That's really key. So, if you look at this graph, if you have a straight line going up, you have a constant positive acceleration. It's not speeding up. It is speeding up, but it's not, the acceleration's not changing. So it's speeding up at a constant rate. When you have something flat like this, you can see that the velocity is not changing over this time, so it's going at constant velocity. This is like having cruise control on in your car. Now, if you have a negative acceleration over here and your slope is negative, that means you have a constant deceleration, or you're slowing down. So on this side, you're speeding up. And on this side, you're slowing down. Okay, so that's really key. This is important stuff about a velocity time graph. Now, let's go to the next slide. Okay, one other thing I wanted to tell you guys about these velocity time graphs. If you see something like this, this means that your acceleration is increasing. Okay, so if you see something with a curved line like this, your acceleration is increasing. And I'm not going to ask you to calculate the slope for this, because it would require calculus and drawing a bunch of tangent lines, and we're not going to deal with that. But if you see something like that, you know your acceleration is increasing. Now, if you see something like this, this means your acceleration is decreasing. Okay, so where can I write this? This means your acceleration is decreasing. So okay, and I'm not going to make you calculate the slope of that either. If any curved line, you will not have to calculate the slope of the curve. I might ask you what it means, but I'm not going to make you calculate that, because that would require calculus and drawing a bunch of tangent lines, and we're not dealing with that. Okay, now in this slide we've got some times and we have some velocities, and we're just going to go ahead and we're going to make a velocity time graph. So in your time, you have 10, 20, 30, 31, 40, 50, 60, and 61. I think I'm going to go by fives. So let's try that. So I'm going to put 5, 10, 15, 20, 25, and I'm going to go all the way to hopefully 65. Now if you notice, I'm putting 5 in between each of these, or each of my marks is 1 square apart. You can see there's 1 square in between each one, and that's what you guys want to do. I've noticed a lot of people like to start here, and then they'll start here and they'll go 5, 15, or 5, 10, 15, and you can't do that. You need to have the same amount of space in between each one. I've also had some questions whether you have to label, if you leave one space between each one here, do you have to do that on the top as well? and you don't. And so I'm going to put, we have, it looks like from 0 to 3. So I'm going to do 1, 2, 3. Okay, I don't have to go by 5s, even though I went by 5s here. I'm going to go ahead and I'm going to label my x-axis, and it's in seconds. You want to make sure you use the units, or else we're going to think that it's, we have to assume elephants, right? Drawing sideways is not easy. Okay, so here's my velocity in meters per second. I'm going to go ahead and I'm going to write velocity versus time. I don't want to forget to write my title, and I want to make sure I get points for that. So I'm going to go ahead and write it. Now, now I just need to plot my points. So at 0 seconds, it's at 0, and I'm going to make my points in pink so you can see them. At 10 seconds, it has a velocity of 1.5. At 20 seconds, it still has a velocity of 1.5. At 30 seconds, still a velocity of 1.5. At 31, which is kind of right here, it's 0. At 40, it's 0. At 50, we're all the way up at 3. At 60, we're up at 3. And at 61, we're all the way back down at 0 again. So let me see if I can draw some lines. Isn't that nice? So let's see what we can figure out from this velocity time graph. We know that right here, it's a constant acceleration. And that's also what's going on here. Both of these sections have a positive slope. At here, your velocity is constant. And if your velocity is constant, your acceleration is 0, which is why you have a slope of 0 here. And this same thing is happening right here too. So we have a constant velocity at both of these flat places. And also here, now here, our velocity is constant, but it's 0. So what does it mean when your velocity is 0? It means that you're stopped. So right there, you are stopped. You are not moving at all. And that's technically a constant velocity. It's a constant velocity of 0, but it's a constant velocity. Now, right here, you're going to be decelerating. Okay, that's a negative acceleration. And you're also decelerating over here. Okay, so there's lots of questions that we can ask you about these types of graphs. We can ask you if there's a constant acceleration, what's going on. We can ask you where there might be a constant velocity, where your vehicle might be stopped, anything like that. We can go ahead and ask you because you should know those things about your graph. Now, this graph has the sides labeled. These are labeled at constant intervals. The x-axis is constant intervals. Your time with units. You have a title. Your points are plotted correctly and they're connected. And so if this was your graphing quiz, you would get full points for this graph. And then I might ask you to calculate the slope at this point or this point. And you could do that. You would just pick 2 points. I would pick the 2 right here because they're easiest, but you can do that. So this is kind of what you guys are going to have to do with velocity time graphs. I told you at the beginning of the year we would do a lot of graphing, and I wasn't kidding. we're really going to do a lot of graphing. But your graphs are starting to look really good, so I'm really happy about that.